Thank you all for coming. My name is Ian Graham, and I've got the honour to introduce this evening's conversation. Nobel Laureate, Professor Sir Paul Nurse in conversation. Introduce Paul, and also acknowledge Tom Whipple, who's the science editor at the Times, and so we're really looking forward to an active conversation between the two of them. I also want to do a bit of a push on their two books, which are here for any of you that are interested in looking at them. I'll be honest, Tom, I haven't read yours, The Battle of the Beams, but I'm sure it's really good. But obviously I know a little bit more about Paul's, What is Life? And in fact, I could say something about it, but I decided this afternoon when I was deciding on what to say, instead of me saying something, I'll just read out a couple of quotes, because it's as good as anything in terms of the context of the man and what he's been doing. Paul Nurse is about as distinguished a scientist as there could be. He is also a great communicator, etc., etc., etc. And that was Philip Pullman. You'll all know Philip Pullman. Wise, visionary, and personal. I read the book in one sitting and felt exhilarated by the end, etc., etc., etc. Platitude, platitude, platitude. That was David Sobel, who I'm sure a lot of you will know, and a lot of you will have enjoyed reading books such as Longitude and Galileo's Daughter. A nearly perfect guide to the wonder and complexity of existence, Bill Bryson. So I think that's as much pitching that I'm going to do for you, Paul. And you owe me at least a pint after that. So a great communicator. And in fact, he did some of that communicating today at lunchtime when he gave a research seminar in this very same room to a similar-sized audience of a lot of them awestruck undergraduate students. And it was a great demonstration of the excellence of his science, but also the excellence of his communication. He kept relatively simple, based on principles of a really complex subject, which is his area of expertise for the last number of decades. How cells divide, one of the most fundamental things in life and what has led to life on Earth. And that's what he's been known for and has won the Nobel Prize for. It was really interesting the way he presented it. I don't know if that will come out. It probably won't come out tonight, which is why I should indulge a little bit in mentioning it. He obviously, like any scientist, prides himself in making breakthroughs that make it to the textbooks. But not only has Paul Nurse made breakthroughs that has made it to the textbooks and has informed teaching and research over the decades, he's now at the point in his career where he's rewriting the same textbooks and correcting some of that earlier work and taking great pleasure in that as well. So, Paul, I think that was really appreciated. And it brought home the message that science, although it strives for truth, is always changing and is always leading to further breakthroughs. And that's one of the key messages, I think, in this world today, that it's based on truth, but there are very few things that are ever absolute, and we must make the most of the understanding that we have. So that's one aspect of what I wanted to mention today. Another aspect, which I took from The Guardian, so it must be correct, and this is taken directly from an interview with Paul about 5 years ago, where it said he famously failed his French O-level 6 times. And I think that probably caused him a lot of grief at the time when he did that failing, because he was wanting to get into university at the time when you needed a foreign language. I suffered from that myself as well, in fact, and I won't expose myself to the same extent as I'm now exposing Paul, but in fact he told me the longer story previously himself, and in fact he managed to finally overcome that by, he was interested in doing a broad-based degree in biology. Obviously there was something about the young man even at that stage, And he talked his way into the University of Birmingham to do his first degree, with the understanding that he would do training in French in parallel with it. I don't know how well that all worked out, Paul, and how fluent you were in French, but at the end of it. But he told me at the same time that it didn't stop him accepting the Legion d'honneur in France and giving his acceptance speech in French. So there's a few turns along the way. The other thing I should say about his acceptance of his undergraduate degree in Birmingham is that he was refused by York, okay, by this very institution. So, and he told me that in about the second step when we were of the stair when we were going up to when we greeted him, myself and our head of department this morning. So it obviously still rankles down there a little bit. But you know, we've got to keep up our standards here. So that's his undergraduate degree. He went on and did his PhD at the University of East Anglia, and then went to Switzerland for training in genetics and discovered this amazing system that he's worked on all his life of a single cell yeast, which taught him and allowed him to better understand the whole process. And obviously from that, because it's the same mechanisms that control our cell division, and when those mechanisms go wrong, result in cancers, which is why the work that he does has been profoundly relevant to health studies and finding solutions for cancer in all its aspects to this present day. So, you know, there are a long list of achievements. I'm not going to read them all out. I hope you probably all have, and that's what's brought you out here on a Friday evening. But they are amazing, the list. I should just mention a few. He's currently director of the Francis Crick Institute in London, which is an amazing research institute, a flagship for the UK scientific excellence and community. He was president of the Rockefeller Institute before he came back to the UK, spent time in Oxford, and I'm not going to read out all the prizes. Perhaps just to say he was also president of the Royal Society for a period, and served for 15 years in the UK Council of Science and Technology, played a big part as Chief Scientific Advisor to the European Union, played a big part in our government coming back to make sure we now have still got a significant role in EU research, which is extremely important. Is highly recognised in government and all its throughout the different parties, and has done for a long time. And that, along with all of the other really generous charitable work that he does. Some of the most important things is, as my career developed, and a lot of other academics who are here, that Paul has done, is carry out some really important reviews of research and research funding. And the nurse reviews, he's now conducted 2 of them, have had a profound impact on how our science is conducted, how it's funded by government. And that is, I don't know if that is something that Tom's planning on exploring tonight, but it's a really, really important role. That's often that often goes on behind the scenes, massively influential. And I've had the pleasure of working with him. We are both Royal Botanic Garden Kew trustees, and he's passionate about fungi and about plants, as well as about all of his other work. And works tirelessly for that cause. He's really committed to collections-based research, for example, and has really been really dynamic in trying to convince government that we need better ways of securing those collections of plants and fungi, and better ways of working with them. And then not to exhaust me even further when I think about, you know, what can a scientist expect to achieve in their careers. He's just about to take on the role of president of the Royal Society for the second time, and only the first time in about 200 years that the Royal Society has taken a president, the same person, back a second time. So I don't know what he runs on, but it's I'm going to try and find out. So with that, I just want to hand over to these two gentlemen for a conversation.
Bonjour, Paul. Ça va?
Bonjour, monsieur.
Look, talk to me about, how did you get into science? Why are you sitting here? How did this begin?
You know, I didn't come from an academic family, but I was, at least I thought I was the youngest child in that family, and which is a bit complicated, but
we'll get into it.
We'll go over that. I used to walk a long way to primary school. It doesn't matter why, but I was. And I just started noticing the natural history around me. And in the winter, the night sky coming and seeing the planets arrive and move around in the heavens. And it really was just an interest in nature and sort of astronomy. And I went to university thinking I'd do ecology, but it was just too wet and cold out there, sort of collecting specimens and so on, and you know, getting up at 5 a.m. to get the low tide and then wandering around in cold water. I couldn't cope with that, and I wanted a nice centrally heated lab which was warm and dry, and so I moved away from that. But that's how it started.
And just because, I mean, going to be president of the Royal Society for a second time, which if people don't know what it is, it's basically a gentleman's dining club for elderly scientists. But you are at the centre of the establishment. So just, I mean, your background is, we'll get on to the really unusual bit, but it's unusual even at the sort of, as you thought it was in 2001. I mean, you were very working class, weren't you?
Yes, my dad was a factory worker and my mum was a cleaner, and we didn't have any books in the house. Well, that's not quite true. We had the Bible, and we had one Biggles book, I seem to remember. I got interested in planes, actually, through that. So we didn't have many books and things. I went a lot to the library, but I was clearly a bit odd. And you know, my brothers and sisters had working class jobs as well. But my parents, who didn't really understand what was going on with me, you know, I went to a grammar school, you know, and so on, just supported me. They just didn't know quite what I was doing, but you know, I didn't have to go and do the paper round to collect money for the house and stuff. They supported me all the time, and I'm constantly grateful for them for that.
And are there any things you remember about science at school in the childhood? I mean, in your Nobel Prize biography, you talk about a teacher called Keith Neal, and you've mentioned him a few times.
I had a teacher, you know, when you're at school, of course, every teacher is sort of, you know, ancient and 50 years older than you. But actually, Keith Neal had been at Cambridge. He was probably only 10 years older than me. And he was a huge enthusiast. I told you I was interested in natural history. So he would work with the children he was, and young adults he was teaching by getting them to do things after school at weekends. You know, he took me badger watching. We did fish development in fish tanks. We collected moths and identified them and stuff like this. And I mean, it was extraordinary. I mean, he was hugely supportive. Much later in life, I met him, and I met him even in my old school when somebody was doing a TV thing. And he was just exactly the same, still enthusiastic. His father was a guy called Ernest Neal, who wrote, if any of you are into badgers, wrote the major book on badgers in the United Kingdom.
So did he get to see you become, presumably, his finest scientific outcome? Did he get to see you win the Nobel?
He did, yes, he did. Yeah. And, you know, he was understated, so he didn't go on about it. He was just, you know, gently pleased. You know? The right thing to be. Really.
You mentioned that the only books you had in your household were Biggles and the Bible.
Yes.
You were brought up religious.
Yes.
How did that change, and has it influenced you, or did you?
It has actually. I was brought up Baptist. My mother was Baptist, and I went to Sunday school and thought I might be a missionary when I was sort of 10 years of age and things like that. As a consequence of this, I actually know the Bible extremely well. Do you know the Bible extremely well? Good. So you're not going to test me on anything. I just thought I'd check that just before I went much further.
Not the religion
and I know the Bible still quite well, and I also know the language quite well. You know, because it's I'm talking about the authorized version, so it's early 17th century, wonderful language, and the Baptist minister spoke in a particular way, and all of this has sort of influenced me in funny ways. But the problem I had was this, that when I went to secondary school and started doing biology, I learnt about evolution and evolution by natural selection and so on. And this wasn't quite the same thing as Genesis, as you probably know, being a science writer, okay? And so I went to see my minister, and I said, look, you know, can't we treat Genesis as something like a sort of metaphorical poem suited to a primitive people looking after sheep and so on, as a way of explaining creation? But why do we have to believe it literally? And he just looked at me and he said, I will pray for you. And I went away and I thought, I don't think that was a good answer, you know. And I gradually slipped, you know. I slipped out of being a Baptist, and then I thought maybe a Unitarian, which is a net for catching falling Christians, as you probably know. And then I gradually moved away, and I ended up being basically atheist, though philosophically a skeptical agnostic, which, believe it or not, is the same thing as Richard Dawkins is. He's not actually, if you push him, he's a skeptical agnostic rather than an atheist.
And so whilst at school, why were you so bad at French? Why was...
I can tell you, my parents come from, well, I've got a theory. My parents came from Norfolk, and this is how my mum and dad used to talk like this, you see. One day I want to give a lecture like this and see if they think I'm intellectual. And I was in London, in Wembley, speaking like this, you know. So I mean, you know, people made fun of me naturally, you know. If you're brought up in northwest London in a fairly working class background and you talk like a Norfolk bumpkin, I mean, you know, what do they think of you? But I had this great trouble. When I see words, I can't see how to pronounce them. I sort of rush at them and make a mess of it, you know, and I get them all mixed up, and I can't remember them. You will tell me how to pronounce it, and I can't repeat it, you know. Now, I'm not illiterate. I can actually speak okay, but I just couldn't deal with it. And, you know, French was different, and I needed to pass this damn exam. And it is true, I failed it 6 times. I mean, I've never known anybody fail an O-level 6 times. I mean, it's like like GCSE.
You must have been determined as well to try it 6 times.
Well, it was I had actually quite good A-levels, good enough to get me into, you know, Cambridge or somewhere, and I took them a year early. I had 6 attempts in spring and summer, and I wasn't doing anything else except French. And there was, and I tried really hard. You know, people say, oh, I didn't work very hard and so on. It's not true. I was completely, utterly, and totally incompetent. I just couldn't do it. And I ended up leaving school, okay, and doing it again, because I had a year spare. And I worked in the Guinness Brewery, actually, in Park Royal. Some of you might be familiar with it. And so this is literally all I had to do was pass it, and I failed it twice again. I think I once passed the oral, actually, and I once got the highest fail grade, I think. And that's my record. Yeah.
Before I move on from your childhood, so we sort of teed this up. So your 2001 Nobel biography, you started it by talking about how you were almost an only child because there was a huge age gap between you and your sister, and it meant that you felt like you were brought up as an only child. But then the Nobel Prize biography, you've added a postscript for the website. Talk me through what happened.
Well, what happened is I told you, I didn't quite say this. I was the youngest child. I had 2 brothers and a sister, and I was the only one who stayed on at school after the age of 15 of that family. I became a geneticist and did wonder. I'm basically a geneticist, cell biologist, and did wonder a bit about my genetics, but I didn't think too much about it. And then when I went to New York, I was president of Rockefeller University. This is 3 years after the...
so 2004.
Yeah, something of that sort. I applied for a green card. And Homeland Security, US style, rejected me, okay? I'm quite good at getting rejections, by the way. It makes you resilient, to be quite honest. They rejected me and I was a bit surprised because at the time I had a Nobel Prize. I was president of Rockefeller University, which is not a slouchy sort of job, and I was knighted, okay? And they rejected it, okay? And the reason is it was a bureaucratic that I had what was called a short birth certificate. Some of you may know what that is, but it's a birth certificate which I now know was invented in the Second World War to hide illegitimacy. And so you see where I'm going to go in a moment. It doesn't name your parents. It names you're a citizen, it names where you were born and when time you were born, but it doesn't name your parents. And the Americans didn't like that, okay? So they said I needed to get a long birth certificate. Now, I knew that a long birth certificate existed because I asked my parents why I had a short one. And they said, rather creatively, it was cheaper than the long one. Okay?
It's very Yorkshire.
Yeah. Be careful, okay? And I believed them, you know? I believed them. And so I wrote away and to the registry office in London, and they sent back a birth certificate. And my wife, who's sitting in the audience there, and myself had been on holiday. We came back into this very big Rockefeller president's office, and I had my PA and her assistant, I had my lab manager and Anne, so there were 4 women there. And then I overheard Anne being spoken to by my PA saying, is it possible Paul got the name of his mother wrong? And everybody's ears sort of picked up, you know? And there was a sort of silence, and everybody suddenly looked at me, and I was handed this brown envelope in which was my birth certificate. And I opened it and looked at it. And the name of my mother was my sister. The name of my mother was my sister. And then I looked around for my father, and there was just a dash, okay, a line, no identified father. What had happened? My mother gave birth to me at 18. She got pregnant at 17. My grandmother sent her to her aunt in Norfolk. She gave birth to me. My grandmother came up and pretended she was the mother to protect her daughter. I think this wasn't so unusual in working class homes of that time because of the shame of the legitimacy. It's impossible for you know, I have 2 daughters, they can't even imagine what on earth was going on. I mean, that this would happen now. And so I just believed all my life until I was age 55, by which time my mother was dead, my grandmother was dead, and my grandfather also had dead. So anybody in my family, I confirmed it because I was born in a housing estate in Norwich, and there was a 12-year-old girl there. I asked my brothers what happened, and my brothers said, well, Mum went to Norfolk and came back with you, which is about all boys can sort of think of, I suppose. And but there was a 12-year-old girl, and who was, I thought, my cousin, but I mean, I'm not quite sure what she is now because everything gets confused. I phoned her up, and she confirmed it and said the entire family was sworn to secrecy, and they kept it for half a century. Amazing story, really.
How do you feel about your mum and sister? Do you feel sad? Do you feel...
You know, what I feel, and it's really quite genuine, everybody was just doing their best for me, you know? They struggled with it. I was registered on the very last legal day to do it, which is my only information that they probably didn't have a clue what to do with me, okay? And it was done at the last moment. And then, of course, just to add to this story, if you want a bit more, for nearly 20 years, I didn't know who my father was. And then last year, I think it was, or maybe the year before, but last year, I discovered my father, which is extraordinary too. And that was through one of these DNA testing programs, Ancestry DNA, that was the one. And they identify individuals on their database who may be related, and there were two people who were related to me, a sort of first cousin connection, which is quite close, and I didn't know who they were. Now, I discovered that about 5-6 years ago. I tried to contact them, couldn't get any response. But then last year, I think it was last year, I can't remember if it's last year or the year before, but I was doing a radio program on the 70th anniversary of the structure of DNA, and we were talking about DNA things, and there's a comedian, you know, it was the Infinite Monkey Cage show, which some of you may know. They have this comedian on there who's quicker, faster, and more intelligent than any scientist who appears on the program, for absolutely sure. And he jokingly said, did any of you lot find out anything about your genetics you didn't understand, okay? And I told the story I just told you, but there was a panelist there. And this was a lady who had been involved in the genetics and genealogy of Richard III, who was dug up in Leicester car park, do you remember?
Yeah, okay. I was there.
Under the letter R, if I remember rightly. And I understood the genetic bits, but to sort this all out, you needed genealogy, which I couldn't do at all. Anyway, I left because I was going to Hiroshima the next day on Japan, and I didn't go to the party they had after it, and I rushed off. And she ran after me and said, do you know, if you do something with, you know, Ancestry DNA and sign something, I could get access to your data and I might be able to help you. Are you interested? And I said, yeah, okay. But I ran off. Next morning, I'm in Heathrow, Terminal 5, and I get an email saying, if you press this button, you know, or something, I can get access, okay? This was a Friday morning. This is relevant in a minute, okay? And so I went off to Japan. I went to Hiroshima. I was in my little business hotel, you know, they're tiny little places in Japan. And on Sunday lunchtime, I get a email from her saying, I think I've discovered your father. Just unbelievable in 2 days. Well, it was my father, and he was a London bus driver, okay. I used to collect bus numbers. I'm a sad person in that bus garage when I was 8 or 9. I don't collect them anymore, but I do know the classes of buses, which is a bit sad. But anyway, so I may have even seen him, but who knows? He had died by then. And the end of the story is that he was on national service at Suez. He came back to his mother's, who lived only 100 yards from where we lived, was there for, I think, about a week, and during that time, my mother got pregnant. He then went off, and I think probably had no idea of my existence. And I'm a geneticist and had no idea about my own genetics.
Moving back to science.
On. Sorry that took so long, but it's a long story.
It's a long story. It's a good story. Your scientific career proper, I think, began with fish respiration.
Yes.
Yes.
How did you know that? God.
I've done my research.
Yeah.
Talk me through your first experiment.
My first experiments were, as an undergraduate at Birmingham University, we had to do a project, a research project for a month or two. I was doing the respiration of fish eggs, and we kept the fish, and I put the egg into a chamber and measure uptake of oxygen. Okay, and this involved looking at a sort of bubble going backwards and forwards, and that you could measure the rate, which I did extremely carefully, and I had very nice oscillations, which I thought probably reflected the division of the cells that were going on in the early embryo. And I did a very careful study about this, the variation of this and the reproducibility of it. It was really very good. And then in the last 3 days of the project, before I had to write it up, I did a control and took the fish eggs out, and I got exactly the same oscillation. Now, this is a bit of a disaster, if you can realise, because I just spent 2 months measuring the respiration rate of frog eggs dividing, when actually there were no frog eggs in the chamber. And what had happened was I was measuring the rate at which the thermostat switched on and off, and the bubble moved around according to the temperature. Now, I had to write this up as a project and then give a talk about it, and I thought the only thing I can do is to do it completely straight, as if it was all correct, and then destroy it at the end.
Were you tempted to not just not have done a control?
No, I'm a scientist, so I had to do the control. I have been tempted sometimes not to do the control, but what you mean is, was I tempted not to report the control? Yes, that's what you meant. No, I had to do that. Yeah. I had to do that.
And then let's move on to the research that made your career.
Yeah, it looks like a disaster, my career so far.
It does. We've done the French, we've got the eggs out of the way. Tell us about the beauty of yeast and what they did.
I work on yeast. Now, nobody's interested in yeast except me and a few other people. But yeast is it's a simple organism, obviously, and you'll be aware of yeast in fermentation, making bread, wine, beer, and so on. But its basic structure is similar to what we call eukaryotes, which is higher organisms, including our cells. So they're not like bacteria, which are a more distant relative of microbial relationship. And so what you can find out with yeast can often be really useful for understanding more complicated cells like ours. And the advantage of working with yeast is it's very cheap, it's very fast, it's easy to grow, but it's got fantastic genetics, which allows you to tackle very difficult problems with great precision. And working with animal cells, you can't do there's such precise genetics in such speed. And so what this meant is I could take a genetic analysis to the problem which I was interested in, which is what controls the division of a cell from 1 to 2, which is what I've worked on all my life. And I took a genetic approach, getting mutants in which this process was defective or altered. And then, by rather simple experiments, try to unravel initially just the logic of how that process worked. The logic, the connections, it was abstract. This gene did this, it worked positively, this gene worked negatively, and so on. No chemistry there, no biochemistry. Eventually, having established that, I then went on to be able to develop methods which allowed you to clone the genes that were responsible, including gene editing, which we invented for yeast. I invented it for my yeast back in 1980, which is, 2 or 3 decades before you could do it routinely in, for example, humans or mice. And that meant that we had these really fantastic tools. People don't in the 20, my Nobel Prize was the first to be awarded to yeast, but in the 20 years afterwards, there's been either 4 or 5 Nobel Prizes which have included yeast work. I mean, it's very for physiology or medicine, and it reflects the fact of the power of the analysis that was possible. Because biology is complicated, and you have to be really self-critical and do very careful experiments with great precision. And when you're working with an animal tissue culture cell and so on, they're changing their genome all the time. They're a bit of a mess. They may have come from your nose or your toe or somewhere, and they will have different sort of controls. You can't make much sense of it. But if you've got a simple system, you can actually apply the logic to it to work it out. And it was really a fantastic organism to work with.
And so what did it show you about yeast and about everything else?
Yes. Well, as I said, I was interested in what controls the division of one cell to 2. And the approach I used, the first approach I used was one that had been used previously with, another researcher who also got the Nobel Prize at the same time, which was to look for mutants that were unable to divide. And if they can't divide, they can't grow and so on. So, I mean, they're obviously dead. So you'd have to use what were called conditional mutants. Conditional mutants means that the gene works under one condition, but not under another condition. So you can keep them alive at one condition, and you can express the lack of that gene function in the other condition. And the most common approach to that is to use temperature. You shift to a higher temperature where the protein encoded by the gene is not stable and unravels, and as a consequence is defective. Okay? And I started that work in Switzerland, which you've mentioned, and continued it in Edinburgh, where I did the initial genetics for this, and identified about 30 genes, I called them cell division cycle genes, that were necessary to complete cell division. Since then, just to put that in perspective, we sequenced the whole fission yeast genome. It's the third eukaryote to be sequenced, actually, not talked about much. And we now know there's 500 genes involved in this process. And at this time, we only had 30, just to put it in perspective. But I think I said I was interested in the control. Now, what we were getting with those sorts of mutants were actually genes that were necessary for the process, but not necessarily controlling the process. And if we use a metaphor of a car, I mean, there are many parts of a car which are necessary for it to go. But you know, you've got an engine, you've got pistons, you've got wheels and so on. But you do not control the car by taking the wheel off or, you know, taking the piston out. You control the car by, let's say, the accelerator. Now, the accelerator, if you put it off, the car stops, which would be the same thing as if you took a piston out. But the real key is that if you push the accelerator down, it goes faster. And that tells you that the accelerator is the rate limiting control for the process, okay? And if a cell divides faster, it divides faster than it can grow. And this means it divides at a smaller size, right? And I identified this first in Scotland, so I called it a wee mutant, you know? I thought it was really funny then. I mean, I must say, wears a bit thin 50 years later, but there you go. I called it a wee mutant because it was advanced into the cell cycle. Now, I'd like to tell you that I thought through all this logic and looked for them, but I didn't, of course. I'd never thought of it. I was just scanning, looking for cells that couldn't divide and got bigger, when I spotted a little patch of cells that were dividing at a small size. And it was like a sort of thunderclap in my head. I just looked at it, and within sort of 10 seconds, I realized it meant it was dividing faster than it could grow. I'd never thought about it. This wasn't, you know, a great moment, and then I looked for it and so on. I could make a story like that. It's completely, I probably wrote it up like that, but it is absolutely not true. It was nature giving it to me. You did have to pay attention to it, I mean, I did pay attention to it. I did interpret it. My colleagues thought it was just a contaminant on the plate, and I was just being stupid, of course. But in fact, that unlocked this whole process. I mean,
and then it turns out that yeast aren't that different from...
Absolutely not. So I went, absolutely the case, sorry. I mean, I went through and isolated more mutants like this. It's long and tedious, I have to say. And I constructed a sort of logical network of how these all reacted with no biochemistry behind it, no explanation that this gene did this. It was just a logical connection. And so that's when I went to the University of Sussex. I developed methods to clone genes, by sprinkling a gene library on a defective mutant and looking for genes that could rescue it. That's how you could isolate the gene. Now, what my lab did, which was unexpected, is when I moved to a cancer research institute, nobody was interested in yeast whatsoever, relevant. So I thought, I've got to make these characters more interested in what I do. And the way to do that is to see, do you, human being, have the same gene? Okay? And I had a lady called Melanie Lee in the lab, postdoc, who said, give me a difficult project. So I said, find the human gene. Okay. And we used conventional methods, which I won't bore you with, which didn't work. 18 months, 2 years, nothing worked. And then I thought we could use a human library. It was the first made by Paul Berg, and he sent it to me from Stanford just a few weeks after he'd made it. Sprinkled the human library, it's not quite like this, but I mean, sort of like this. Sprinkled the human library, which has got 25,000 genes, onto the yeast cell that is defective in the gene that was important, right? And so couldn't divide. And if there was a human gene that did the same job as the gene that was defective, then that cell could grow and divide, and it would appear as a colony on the plate. Now, that experiment has absolutely no right to work. I mean, yeast cells and human cells diverged from each other probably 1.3 billion years ago, 1.2 billion years ago. And what we were demanding was that the gene functions would still be sufficiently similar that one would work in the other organism. Now, and so everybody thought this was mad and kept telling Melanie, Paul's off his rocker, just sort of go do something more sensible. But actually, it did work, and it was in the 1980s. To actually confirm it, we had to do lots of tests and so on. And I remember it was a very stressful time, because if this was true, you understand, it would mean that the cell cycle is controlled by exactly the same process in humans and yeast, and therefore everything in between. So this is a big thing. And sometimes I'd go home at night and say, I'm just going to imagine this evening that it worked, because I'll go in tomorrow and the experiment will show that it hasn't worked, And I just want the pleasure of thinking it's worked. I mean, it must sound odd to you, but honestly, it's true, And the final part of that was we sequenced the gene. We could now do it in about, a minute, but it took a couple of months to do it then by the methods we had then. And as it came off on the ticker tape, I could see that the protein that was encoded by the gene was 62% identical, every amino acid, to the yeast gene, and there were about 25% extra that were very similar. So it was hugely conserved, even though there had been 1.2 billion years of evolution opposite, so 2.5 billion years, and it was working. And that just was, nobody was thinking of that or could imagine it, and you journalists weren't interested in it, I can tell you. No,
I wouldn't have covered your yeast paper.
Nobody was interested. It just came like a thunderclap, actually. And, I don't think I published it in Nature, but they just didn't quite know what... They realised it was important, but because it was so left field, it didn't attract much attention. But that was the critical experiment. After the Wee mutant, they're the two big things that really worked it out.
We're running. I want to make sure we have time for questions, so I want to move on to the present.
Yes.
we live in the Chinese curse sense, we live in
Interesting
interesting times.
yes.
Now, I joked that the Royal Society is a gentleman's dining club, but you have let in some women.
Ho, ho, ho. Yes.
Explain what it does and also how things going on in the US are expected.
Yeah. The Royal Society is the British Academy of Science. It's the first real academy that's certainly been in continuous existence in the world. It's founded in about 1660, 62, so it's been around for 350, 370 years. It is pretty good. I mean, it elects people who are pretty good scientists. There's you can't get out of it until you die. So I mean, normally anyway, it is the most distinguished academy for science in the world, together with the National Academy of Sciences in the US. So they're the two that really matter. Now, whether it has any impact on anything depends on the fellows and the elected council and the officers at that particular time. And sometimes it can, and sometimes it doesn't have so much impact. But if it's working well, it is, if you like, a thermometer for high-quality science and a place, a forum, where discussions can occur and policies developed which will support the highest quality science, which is important for the future of our humanity and our nation and everything. So it can play a very, very important role. Its offices is just off the Mall, so it's right in the middle of in London, and it is hugely respected most of the time until it isn't, and because it's well, it's got a couple of problems. One is it's got 1,000 fellows who always, each individual one is talking for the entire fellowship and tell the president what they should be doing, okay, which is a bit complicated.
It's great for journalists. They all talk to us, but then they're too cowardly to go on the record.
They never go on the record. No, they'll talk to you, but not say
no.
I realise. And but it is important if done well.
And one of those 1,000 fellows at the moment is going to be one of your agenda items, I'd imagine, when you take over properly as presidentship.
Who is that?
You might have seen him in the news recently.
Mm-hmm. I think we're talking about Elon, okay? Elon Musk. Yes, so Elon was elected, not under my presidency, I have to say. He was elected for his contributions to rocket technology and electric cars. A perfectly legitimate thing to be elected for. He wasn't himself a scientist, but he delivered high-quality applications of science to engineering, and there's a category that deals with that. Brunel, for example, was a fellow of the Royal Society, and for the same sort of reason, building railways and so on. Was probably equally difficult person to Elon as well. Now, the problem has come that because Elon is not behaving entirely normally, in the sense that he says things that you wouldn't normally say, I would say, and he behaves in certain ways that are a little odd, and some people have taken offence about it. But I was pretty tolerant of that. I'll change that in a moment. Pretty tolerant of it, because the Royal Society isn't a dining club, okay? And if it was a dining club, then you'd say, if you say unpleasant things and you're not good, then we should expel you. But he was elected for something which it still stands, okay? And it has to be said, we have quite a lot of other fellows who you might not want to have dinner with as well. And I'm not quite sure when we would actually draw the line to stop it if we started going down that route. However, what Elon has done, which is sort of more difficult to deal with, is he's had this massive attack on science, or at least to be more precise about it, on publicly funded science. I think he's actually I know because we've been in correspondence, he's very supportive of commercial science, which is what he does, but he doesn't, I suspect, see much use for discovery science. I mean, there he's completely wrong. So he has behaved in ways that have really damaged the scientific endeavour in the United States. And I can say more about that in a moment when I finish with Elon. And so, or Elon's finished with me perhaps. But he said things which have instigated things with his Doge stuff, which is actually destroying universities, great universities in the US, destroying science, destroying people's careers. And this has now taken us to a different position, that he's now attacking the the fundamental scientific community. When he was just playing politics, I'd say, we'll just leave it alone. You know, that's not why he was elected. Now he's attacking the scientific community. It makes it a bit more complicated. I decided, the society didn't quite know what to do because we never had anything like this. I should say, in the 400 years, we've only had 2 people who have been asked to leave the society. One was the Astronomer Royal, actually, who didn't pay his subscription. And the second was an officer, I believe, who was stealing money from the Royal Society. Okay, so they're the only 2 that have gone. Nobody's been got rid of because for political reasons and so on. And we've had Stalinists for sure in the Royal Society. So it doesn't happen that we get rid of it. Now the media, you lot, sort of say, why haven't you got rid of him? And then we get people saying, you know, I don't want to be part of this dining club, except they don't call it a dining club.
I'm sorry, it's not a dining club. It's really important.
Yeah, it's really important. And so it's become a cause célèbre. Now the problem is the society was a bit static in its response. So some fellows were upset and they weren't listened to very much. And secondly, nothing was said in public, and so it just festered. You would agree? It festered.
Yes, yes. And
so I then volunteered to contact him myself, because I'm not, at this moment, any officer in the society, to open up some dialogue with him, which I have been doing over the last month or 5 weeks, exchanging. He's replied to this, and I've basically been asking him to consider what's happening in the United States to American science and see whether he could do something to improve the situation, which is pretty mild, okay, and we've not come to a satisfactory conclusion as yet, and I'm having to decide what my next steps might be.
And do you think that, so you said when it's political, you've had plenty of people involved in politics in the Royal Society. If it becomes scientific, do you think that the people who are calling for him to leave have more of a case if he's...
Well, I think it makes it a more complicated situation. I'm giving my own personal view. I personally wouldn't put him through... We've got processes in place that have never been used to see whether a scientist, a fellow should be ejected, which have never been used, okay? Because they weren't even in place before. I think it wouldn't... I think, A, we should criticise his position clearly in public. I definitely think we should be doing that. And 2, we should ask him to consider this is a possibility of whether he wants to continue to be a fellow. I personally wouldn't eject him.
Yeah, okay.
That's my position anyway. I mean, it could change, and my position isn't worth anything because I have no authority.
Thank you, and thank you everyone for coming. I should say, for the sake of all of my contacts, once again, the Royal Society is an excellent institution. And also for the sake of the finest dinner invitation I have every year, which is your summer soiree, that I very much want to come. They have 2 coaches, one goes to Oxford, one goes to Cambridge.
And we go on the underground, yes.
Look, thank you very much, Paul.
Thank you.
Thank you.
Thank you.
Hello everyone. My name's James Chong. I'm currently head of department in the biology department here at the University of York, who've been hosting Paul and Tom today. I've been asked to say a few words of thanks. I will not keep you very long at all. I just want to point out the biology department still offers a broad biology degree for those of you that are interested, and we are accepting applications from budding Nobel laureates. I consider Paul to be my scientific grandfather because I did my PhD with one of the people who worked in his lab. And so I've known him for a really long time. My lasting impression of him when I was a PhD student was him chasing everyone else around a laser tag place in Warwick after a scientific conference that Cancer Research UK used to hold. I think you can probably agree with me that he is an incredibly honest, but also very compelling speaker. And that's an absolute inspiration as a young scientist and continues to be an inspiration as a somewhat older scientist. So as I said, I'm not going to be very long. One more plug for the books. I'm not on commission. They are available outside, as are drinks, and we would invite all of you to stay and enjoy a drink with us after this. And I'd just like to thank once more both our conversationalists for both incisive questions and answers, and for their generosity in giving their time, particularly Paul, who's been here all day today.